Example 3, we're doing the same three things. Graph the function, find f of 0 and f of 3, and state the domain. So for part A, graphing, we're going to make our table. So we have two equations here. F of x, which is y equals negative x plus 2. And then we also have when y equals x plus 4. So what number has to go in both of these tables? Where is this graph going to break? Right here at 1. We have when x is greater than or equal to 1 and when x is less than 1. So at 1 is where this graph is going to break into two different equations. We're going to have something over here to the left of this graph and something over here to the right of this graph breaking at that x equals 1. So we really need to know what is happening when it is changing. And so that 1 is the first number that we have right there. Now let's talk about open circle and closed circle. Which one has an open circle, the first one or the second one? And that's going to be the first one here, which leaves this one to be an open circle. Why? This one is when x is greater than or equal to 1. So if it equals 1, it needs a closed circle, including that number. This one is simply when x is less than 1. So it does not include that number, open circle. So now let's fill out that table here. If we have when x is greater than 1, use this as an arrow here. We're talking about all of these numbers here to the right. So I always go to that next one, but you can skip 2 if you want. You can do 3, you can do 4, you can do 5. It doesn't matter. You just need something over here that's greater than 1. Now I'm going to go ahead and do 2, 3, 4. But you need a minimum of 2 points. So if we just did 1 and 2, that is technically enough. But to make this more accurate, puts a couple more numbers in there. So let's just go ahead and fill this out. So when I put in a 1 here, we're going to have negative 1 plus 2, which is 1. Negative 2 plus 2 is 0. Negative 3 plus 2 is negative 1. And negative 4 plus 2 is negative 2. So I'm going to go ahead and plot those and graph that side of my equation. So at 1, 1, we have a nice bold closed circle and then regular points from there on out. 2, 0, 3, negative 1, and 4, negative 2. So we are starting at that pink line, at that bold point, and going through our other points. Okay, so there is the right side of my graph. So now finish this table to get my left side. So this one says when x is less than 1, you can also use this as an arrow, everything to this side of 1. So the next logical one is 0. Then we'll do negative 1 and negative 2. Okay, you need at least 2 points. I like a couple more in there just to make it nice and accurate. So plug these in. 1 plus 4 gives me 5. 0 plus 4 is 4. Negative 1 plus 4 is 3. And negative 2 plus 4 is 2. So at 1, 5 up here, we have an open circle. Then the rest will be the regular points. So 0, 4, negative 1, 3, negative 2, 2. One super common mistake that I see on these is that graph that has the open circle. You guys will just do open circles throughout the entire thing, but this is the only open circle on that graph. So once you do this bold point and this open circle. The rest are just nice regular points that we have on there. And this is going to go from that open circle through the rest of it. Okay, so there is my graph. So part B wants us to find f of 0 and f of 3. F of 0 is right here. So this equals 4. And f of 3 is right here. This one equals -1. Part C, state the domain. So last time I used the graph. This time, let's use this right here. This one is talking about every number that is greater than 1 and also equals 1. And this number is talking about everything that is less than 1. We're talking about every number possible. So -infinity to infinity. You can also see that using this graph going left to right. We're going arrow, -infinity. Here, I have at least one point that equals 1, which is this point right here. So it doesn't take a break, and then it's going to keep going and go down forever, positive infinity.